My name is Edward Joy. I work at the London School of Hygiene and Tropical Medicine, where I'm an assistant professor in the nutrition group. I think Harvest Plus were initially invited to come and talk today, and unfortunately no one was able to come. As Greg mentioned, Harvest Plus work closely with GAIN, and where GAIN really have done a lot of work to promote fortification, Harvest Plus have done the same thing for biofortification. What I did do is I met with Ekin Birol, who's one of the core staff at Harvest Plus, earlier this week. She gave me some slides. What you'll see, a couple of the slides will have the Harvest Plus logo in the top left corner. It's a sort of blue and green plant slash human figure. So those will be Harvest Plus slides, and I'll do my best to cover a bit of what Harvest Plus do around the world. I'm not a statistician. I do, however, work on micronutrients and biofortification. I work on a couple of trials testing the efficacy of biofortification in Pakistan, Malawi, and Ethiopia. And just one more thing before I go on. I was one of the things I was asked to talk about is some of the challenges that we face when we're setting up these trials in the design, and also to have a little think about the ongoing monitoring of the effectiveness of biofortification. Here's one of Harvest Plus slides. These are the crops that Harvest Plus have worked on primarily, the focus crops for their biofortification efforts. And just to recap on what biofortification is, it's conventional crop breeding, so where we would normally where crop breeders would normally focus on developing varieties with high yields, pest resistance, drought resistance, and so on. The biofortification program has added another requirement or another target for these crop breeders to try and meet, which is to produce crops with greater concentrations of vitamins and minerals in the edible portions. So these are the crops that they've focused on to date, and the minerals that they've tried to breed into these crops. And you'll see here that these are primarily staple crops, staple grains, roots and tubers and so on. And there's a reason for that. Just like the fortification story, the idea is that these will reach the most number of people possible. So in a country like Malawi, around 98% of the population eat maize on a daily basis. So if you can biofortify the maize varieties, get more minerals and vitamins into the, or provitamins into the edible component, into the grain, then the idea is you'd reach potentially 98% of the population. Biofortification and food fortification are complementary. And what we see in low-income settings is that a lot of households, particularly the poorer households, will consume their staple food that's been processed either at a local mill or even at home manually. So in these settings, it's quite hard to implement a fortification program where you're trying to add minerals and vitamins at the processing stage. It's very hard to regulate, and there are safety issues as well as long-term cost implications. So the idea is that in these sort of settings, if you can get the vitamins and minerals into the crop as the crop's grown in the field, then you'll be getting it into the diets as well. So the idea is this can go alongside a fortification program that reach different populations. I should have also mentioned when I was just recapping on what biofortification is. To date, most of the biofortification work and research that Harvest Plus have done has been looking at the crop breeding side, so what you can do to breed varieties with greater concentrations of minerals. That's not the only way to biofortify a crop. You can also, through agronomic techniques, increase the concentration of micronutrients in the edible portion. So that basically means anything that a farmer can do, either treating the soil or, in some cases, spraying micronutrient fertilizers on the leaf of the crop. And this is sometimes done anyway for the health of the crop, but there are some examples of where it would be a cost-effective approach to address human micronutrient deficiencies. And in fact, there is an example of this being implemented at national scale. And it was started in the mid-1980s in Finland, where they started putting selenium in their fertilizer. And that, again, it was a national mandatory scheme. And there was no pre-testing of what would happen, but as they looked on a cohort of about 60 adults, I think it was, just prior to the national mandatory fertilizer recommendation, and then subsequently 5 5-year time points, they've seen the selenium concentration in humans rise to a level that they're happy with. So there are two approaches. You can either go the breeding route or the agronomy route, and again, those two routes are complementary as well in some cases. This map Greg showed as well, so I won't dwell on this. This is another Harvest Plus slide. Countries and crops where biofortification has been released or is being tested, predominantly in the global south. Does biofortification work? Just to unpack this question briefly, the first step of the research is to test whether you can get it into the crop. And that can actually be harder than it sounds. But sometimes what you find is you can get higher concentrations of minerals into the crop, but you've done it with a yield penalty. So you've got a crop that doesn't not yielding quite as well. And that immediately limits your ability to roll it out and the sort of mechanisms that you can use to encourage farmer uptake. So that's been quite a challenge. But there are plenty of examples where it's been achieved. The next step is to work out if it's in the crop, does it get into the human? And these are the trials that I've been working on recently in Pakistan, Malawi, and Ethiopia. What we might call a nutrition efficacy study. Then, if it does get into the human, you also still need to work out whether the farmer's going to take up this variety. So there might be some traits in there that the farmer likes, but some that they don't. You also need to know whether the consumer is going to accept it. And here I've taken an example of maize with provitamin A that's been bred into the grain. And you can see, obviously, there's a visual difference. When this was initially tried in South Africa, I think it was, people thought yellow maize, that's for the livestock. So great, biofortify the grain, but it's only going to give a bit of a benefit to the livestock health, not straight to the humans. So there is sometimes a bit of work that needs to go alongside this in terms of explaining what's gone on and encouraging uptake. And finally, at a kind of programmatic level, again, just like the fortification story, you need systems and you need mechanisms through which the biofortification can spread. So when we ask, does biofortification work, a lot of the studies have been broken up into these kind of 5 stages. The first 4, you can say, is a kind of proof of concept. Under quite controlled conditions, you can test each step of it working. And the 5th is what you might call a kind of programmatic or policy effectiveness study. I don't have much time, so all I'm going to say is there are over 800 peer-reviewed publications now on biofortification going through these 5 steps. Harvest Plus does a really useful job of every 6 months collating all the evidence. You'll see a lot of the studies to date have been commissioned by or in collaboration with or funded by Harvest Plus. I think a lot of other research groups are now picking up the mantle and doing some of this primary research as well. But Harvest Plus collates all the evidence into what they call an evidence brief, and the August version of that has just been put on their website. Just to move on to some of the challenges now, studying biofortification and does it work? There are lots of challenges. I'd say on the trial design side, when I'm looking at the nutrition efficacy side, the design of the trial is not necessarily complicated. It can look just like a 2 or 3 arm trial of a drug trial or something like that. But there are some factors that make the implementation of the trial quite challenging. Firstly, just a comment on baseline information and environmental variation. I've got some notes here, which I just need to refer back to. So there is a big difference between testing a biofortified product and a medicine or a vaccine or something. And there are many differences, but one of the big differences is that your biofortified product is grown in a field and is subject to lots of environmental variation. So here, for example, you can see a map of soil zinc status in the irrigated areas of Pakistan. So we can roll out a biofortified wheat product, as is currently ongoing in Pakistan, but we can expect its performance, so the same genetic material, to perform very differently depending on where it's grown. And here you'll see ranges in the dark red where the soil is virtually certain to be zinc deficient, through to dark blue where it's exceptionally unlikely that the soil is zinc deficient. So your genetic material will perform very differently depending on where it's grown. And this has implications for if you're trying to do some kind of program effectiveness study and so on. You need this kind of spatial information and spatial understanding of the data. These data actually are informed, come from the work we're doing in Pakistan and come from a collaboration with Fauji Fertilizer Company, FFC. They go around testing soils free of charge for farmers, and they have provided that data to us so that we can map it and look at this, the zinc status of soils. Just again, coming back to the agronomic method of biofortification and the genetic method, they are complementary again. So you could grow a biofortified variety of wheat on a zinc deficient soil. You might need to add zinc containing fertilizer for it to meet its genetic potential. Just another comment on baseline information and environmental variation. It's not just in the soils and crops that we see this. We do see it in the humans as well. This is from some ongoing work in Malawi in collaboration with the National Micronutrient Survey team in Malawi. Here we've mapped the probability that an individual in any of these locations in Malawi is deficient in selenium against two cutoff points, so more stringent cutoff point on the right. So again, we see environmental variation in our baseline populations. That's spatially dependent. So again, big implications for when we're trying to study the effectiveness of biofortification. With selenium, the approach that could work with biofortification is putting selenium in fertilizer. The genetic approach wouldn't work because the soil has such a strong control over the crop concentration. And it's actually soil factors that underlie this variation in human selenium status. Another comment on some of the challenges we have in this research field. Nutrition biomarkers. For some micronutrients, it's really hard to test human status, and zinc is an example. There's no specific and sensitive biomarker for human zinc status. So if you're trying to run a 1, 2, 3, even 6-month feeding study, there's no biomarker that is specific to zinc that would be expected to respond in that kind of time scale. So it's really hard to measure some of these nutrient deficiencies. The last point I'd like to make about challenges is that with biofortification, we're working through food and not through medicine. And this has a number of implications. Some of the implications are good. People don't like taking pills on a daily basis to feel better. So that's good news, and is one of the reasons why biofortification could be very successful. But there are also some challenges. Typically in these kind of studies, you're working with people who don't feel unwell, don't think they're unwell, and not seeking healthcare. And yet you're going to them and saying, you're probably deficient in a micronutrient. You can't tell. I think it's likely we're going to ask you to eat this, and we're going to test your blood, and you might get a bit better, but you're probably not going to feel anything. So it's quite tricky asking people, and you're asking people to change something quite fundamental about their behavior, and often something quite fundamental about their culture and society. You're interfering, with their staple food. And that can be quite challenging. Sorry, I meant to have an image that goes alongside this. This was us. This was in July in Malawi. We were visiting a village for the first time where we're planning to run our efficacy study, meeting the community, asking them what sort of concerns they would have about switching from their normal way of eating and processing their maize to the flour that we're going to distribute for the trial. And there were lots of questions that came up saying, it looks the same, are you sure this isn't some kind of family planning program that you're trying to roll out? And all sorts of questions about, all sorts of suspicions, you could say, about what we're trying to do there. And I think that is a big challenge. People now have grown to trust the hospitals and the medicine that they get in the hospitals, and we're coming in and giving them something quite new. Very last point here, this was another Harvest Plus slide. It is going to be challenging as biofortification is rolled out to measure its success at a programmatic scale. And there's a long chain from the biofortified variety being released to it being effective. All of these things need to happen for biofortification to work. And Harvest Plus are doing some monitoring and evaluation. And they have a recommended set of 30 indicators to measure effectiveness. I just mentioned that they've been doing work in this area. And just finally, a quick plug of the work that we are doing at LSHTM with partners in Ethiopia and in Malawi on the Geonutrition project funded by the Gates Foundation, and also in Pakistan under a GCRF project funded by the BBSRC, led by University of Central Lancashire. That's where I'll finish. Thank you.